So we're going to talk about the greatest common factor, and we've done that before when we were working with fractions and trying to reduce fractions. So it might help on this first one if I kind of write it out a little bit here. So we're trying to find the greatest common factor of this term, and this term. So I have 25 m to the fourth, and that means it's 5 times 5 times m times m times m times m, if you wanted to think of it in terms of a prime factorization. Okay, so the next term I have is 35m cubed. So I could think of it as 5 times 7 times m times m times m. And then finally the last one, I have 20m squared. And so that's 2 times 2 times 5. If you break down 20 into 4 times 5, and 4 is 2 times 2. So I'm looking at these prime factorizations, times m times m. And then what we want to see is, what do they have in common? Well, do they all have a 5? They all have a 5. So that will be in the what we call the GCF, the greatest common factor. So greatest common factor is GCF. It's the greatest factor that divides into a term, okay, evenly. Now, do they all have another 5? No. Do they all have a 7? No. Do they all have a 2? No. Okay, so we need a 5. That's it for the numeric part. Now, what about the m's? The m's are actually a little bit easier. They all have at least one m, and they all have another m, right? So it's like the smallest number of the variable. So that's going to be m times m. Now we're not going to write 5mm, we're going to write 5m squared. That would be the greatest common factor. Now you don't have to do that chart. You might be able just to look at the numbers and say, well, what's the biggest number that goes into 25, 35, and 20? And then look at the letters and see, well, which one has the slowest exponent, okay? So that's that problem. We're going to do a bunch of these, so you'll get used to them, but that's an introduction.